Hello, 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 everybody. Root Beer here with question 25, the very last question on our 2009 Fermat paper. In the diagram, three circles of radius 10 are tangent to each other and to a plane in three-dimensional space. Oh, good, three-dimensional geometry problems. I make no secret of the fact that I'm never good at those ones. Each of the circles is inclined at 45 degrees to the plane. Okay, so if I were to draw a line along the circle and a line meeting it that's along the plane, we'd get 45 degrees. That's what that means. There are 3 points where the circles touch each other. I'm going to guess by symmetry that they're all the same height. These 3 points lie on a circle parallel to the plane. And the radius of this circle is closest to. Okay. So I'll get my calculator out. If it's not already out, it's out from the last question. But I'm going to probably need to round some things out a bit. Okay. So, well, I think first things first, get a copy of the picture to use. So, big picture that we're going to scuff up, and then we'll make smaller details later. So, one circle, two circle. I probably don't really need the third circle. But, okay, he touches there, and there, and there. So they hit the plane, and I'm going to use some colors. So touch here, touch here, touch here, form a nice little circle. Now, all of these are radius. It's radius 10 or diameter 10? Radius 10. Okay. So, points of tangency, immediately I want to start connecting up. So, 10 there, connect to points of tangency, and then a 10 down here. So I've got a line going along the circle that hits this intersection point. Makes me think 45 degrees here. Okay. So, what can we see? Well, the circles being parallel mean that these points of tangency are all the same sort of height away from the plane. Probably some height h that I'm going to need. Well, so if I draw in a diameter, it won't pass through these lines, but I'll make this nice 45-degree angle. And this circle and sort of maybe a circle I draw through the points on the bottom should have the same center. The circles are almost begging to have their diameters extended out to this top point. And so I get... My picture looks like a cone, although it's not exactly going to be a cone that we need to consider, because this red circle is not going to lie along the cone. Right? No, it's not. Right? So the red circle bulges out above this circle over here, whereas my cone lies flat along this long diameter. So we actually sort of get the red circle going out and above it as it goes between those 2 points. So we don't quite get a cone, and a cone object isn't quite what we want to use. And finding the center here would... Well, how would we find this center? We wouldn't even need the circle there. We would just need... If I knew some of these distances, would be... Actually, I don't need these distances because I've got that 45-degree angle. Okay. So, just looking at those... I'll try and color code it so we can... So, looking at those purple diameters that I extend up to the top, they have these nice little intersection points with the plane. And what I'm going to do is I'm going to So I'm going to say, well, by symmetry, these guys all lie the same distance away from the point directly below this center. Okay? And that's the height of this, well, I guess it would be a tetrahedron when everything's added up together. But, so we've got this sort of big R. I'll reserve little r for that small radius I want to calculate, but we got this big R here. And we have 45 degrees here. And if it's a height, we get a nice little right angle. So this is also R. But our diameters stop somewhere up here. So that's annoying. Okay, I thought we were going somewhere with it. And, you know, this might still be fine, but... I'm not entirely sure, because I can't figure out capital R from this. I should be able to, but I can't figure out capital R from this. So I think we might have to bring the circles back for a moment. We aren't given any other information, just that one length. 10 and 45, and then just a whole bunch of tangency. That's it. Okay, let's go back to the big picture again. Or maybe I have to redraw it. So I connected up those points of tangency, which are, you know, fantastic. I'm going to get sort of a smaller, and it's also going to be equilateral, but a smaller triangle here, because the big base here is equilateral. And this is our intersection points. And so I think if we look, so I often find that sometimes the trick to a 3D geometry problem is not focusing on the 3D picture, but actually looking at a series of, you know, side shots and this angle and top downs, and that projects it and makes it purely a 2D thing. And I'm much better at 2D geometry, and I'd say most of you out there are much better at 2D geometry. What is with me today? I can't seem to speak. So I think if we look down, I'm going to see some equilateral triangles, and that might give me something. So we have this big equilateral triangle with these bases, and then we've got this center point here, and into here is this R. Okay. And so, you know, my circles sort of flatly, they turn into weirder, more oblate discs here. And, oh no, they don't hit the center. They don't hit the center. Alright, that's the problem. If they hit the center, then the diameter would be this hypotenuse, and my life would probably be a lot easier. Okay, R there, R there, R there. Now, if I know R, I can figure out the side length. It's an equilateral triangle. We don't have to worry about this. If we need it, we'll need it. Or if we need it, we'll deal with it. But our circles sort of rather fatly stick out, and they go just a length 10 there. But it is enough to get them to... I don't want to have to keep redrawing this. I'll draw the circles first. I'll draw the flattened sort of squishier circles touching. And then I'll draw in my... They're not going to look like perfect circles because of the angle they're on, but if we're looking at it from the top. But here we go. Okay, so we can get to this center point. And so we have some distance, 10, but we go a little further with this length, and these R's look like they're flat up against everything. Okay, but then we have these tangent points here, and they also should give us a nice equilateral triangle, which I have labeled blue in the previous picture. And so it's also an equilateral triangle, and the R, the radius, is going to... Draw a bigger picture right here. The radius is going to be little r from this same center. It's always this same center looking down from the top to the sides there. So it's going to in some way be similar to capital R, I guess. Well, I'll tell you what we can... So because it's an equilateral triangle, I'm just going to draw it in black just because I think it'd be a little easier to see. So to the center, with these R's here, they're going to, when they hit the center, we're going to split the 60-degree angle into 30-degree angles. And I can figure out the side. Although I suppose I could just drop a perpendicular and get 30, 60, 90 triangles. And so then this would be 1/2 R. And this would be root 3 over 2R. And so the sides here are going to be 2 copies of root 3 over 2R, which is just root 3R. Okay. So what have we got on our circle? So if I just look at the face of a circle, so if I look head-on at a circle, whatever, we'll get tens, and then a 10 down here. But now this is root 3 times the R that I want. And that should get me... Well, if I knew this angle, we'd be all set. But I guess there's the problem. I don't know... exactly what we're going to have here. But if I were to... Okay. I have an idea, but I want to draw a big picture to sort of try and really explain it. Plain. I'll try and keep the circles the purple that I've been using. I'm going to have... do I want one circle at front? No, I think just as long as it's fat enough, I'll be able to draw on it. And then I'll have another circle. I'm just going to, label the tangent points. I don't really need that third circle drawn in here. Okay. So the equilateral triangle, and it is going to be an equilateral triangle connecting these 3 points. It shares the same center. Fine. But I'm going to use that r over 2 that I had. Little r over 2 that splits this up here into a root 3 over 2r and a root 3 over 2r. That goes right to the center there. And these are 10s. And then we've got a 10 down here connecting this. Now, extending this guy out to the top here, we'll have r over 2, which is this length, here, to this height is the same as the full height here, or the big R to that full height. And that might at least get me some sort of relationship between little r and r, if not little r and 10 here. What's my pen doing? Okay, so that's my plan. If things didn't just get screwed up there. But sort of the question is, I think that's just going to give me a relationship between the sort of little r and capital R, and I don't really have any ideas to the capital R yet. I just want to clean up whatever it was my pen decided to do there. Sometimes when I've been recording for a while, the pen likes to jump around, as though I'm not paying attention to it. It's old software. I really should upgrade. Alright, so there are my pictures back and mostly intact. Okay, so we'll get similar triangles here, and it'll always... Oh, it'll be a 45, and this will be r over 2. Oh, okay. Yeah, so that'll because it'll be hitting the line, the diameter of the circle at the same length. And I think I said earlier the diameter was 10. It's not. It's 20. What, if anything, does this tell me? I'm not entirely sure. I'm going to take away this tiny little r because he's confusing me, making me think that I know a length that I don't. Okay, so that 45 is helping with the r by 2 and the r by 2. Okay, so that also tells me, let's use another color, that tells me this orange distance will be root 2r by 2. Just use the Pythagorean theorem. So that's how much I extend from 10, and then this amount that I can figure out in terms of r. It's something in terms of r. And then I'll be able to get capital R in terms of r, and then figure out this height in terms of the little r, and that might in some way be good. That's the current plan. Okay, so let's start putting a few things into action, shall we? Okay, so on the circle, connect up to the center, 10, 10, 10 here, and then I know each of these is root 3 over 2 little r, so by Pythagoras I can get this in terms of r. So that's going to be 10 squared, 100, minus 3r squared over 4 is going to be that distance. So 400 minus 3r squared over 4, I guess, and then if we square root it, it's going to be something, something unpleasant, I'm sure. But this distance here is going to be 1/2 root 400 minus 3r squared. Which seems a little ridiculous. Although, I guess I don't know what r is, to be honest. Okay. Now, that distance, so 10 plus 1/2 square root 400 minus 3r squared, plus the root 2 r over 2, that is the hypotenuse up to the top, is going to be root 2 times that capital R radius. Okay. I'm really uncomfortable with this expression here. I feel like it should be cleaner. I feel like I did something wrong in my reasoning, and I really hate doing something wrong in my reasoning with a 3D geometry question because I almost never see it. It's got to be an intuition based on formulas not looking quite right. Okay. So I've got... Now we're looking at a side view. R here. Root 2 over 2 little r. R over little r over 2, little r over 2. This whole height here is capital R. We have the center there. He's 10. And then we have the 1/2 root 400 minus 3r squared that's making me upset. Fine. So I can get all of this in terms of little r. The question is now, what would that accomplish? What in the world would that accomplish? I feel like I'm missing a piece of information. But I've used the 45 degrees. And there's 45 degrees here. So that's fine. And I've used the 10 a little bit, but not much. I guess I can finally get rid of one variable. The question is just, what has that honestly got me? I need another equation. That's what I need to be on the hunt for. Another equation. So there's nothing new in the, or nothing that they can tell me in here, is there? They're all parallel to the plane, so it's got to be the same height away. I don't think I can figure out what that... Well, I can figure out what that height is. It's the capital R minus the little r over 2. I just don't see how that helps me. I've used the tangent points. Have I really used this? Yeah, I've used that tangent point as well. Radius 10. I feel like it's all been good work, although I'm not entirely happy with the 400 minus 3 r squared. But I'm missing a connection or an angle or just a picture that is going to help me out here. And I'm just not entirely sure what I need, which is a shame because unlike a written question, when you get stuck here, you're just stuck. So I wonder, could I use the equilateral? I haven't used I mean, I've got one equilateral triangle, but could I use the equilateral triangle at the base anymore? Draw a picture of him. So I got this nice center point. Got this R here. R here. And R here. And so, similarly, this is root 3r on this side. I mentioned we could get that if we needed it. Well, we already saw a similar sort of thing with the little r's. So that's the difference. That's the distance between the points where the circles are touching the plane. But I don't see how this might grant us any new information. Alright, so... I suppose... Okay, so we got these tetrahedrons. I'm not seeing anything else with them. Now, what if we just go back to previous picture? Anything jumping out? I still don't like that 400 minus 3r squared, but I'm living with it. Because at least that's something. Now, we've used these points of tangency, these points of tangency right here. But, you know, have we used them to their fullest? Because with a point of tangency on a circle, usually you expect sort of a right angle. And I can't really get them down here at the plane, but... Well, I think... Let's use, I don't know, green or something. If if I draw a line through the points of tangency, I think by symmetry, will it reach the top? I don't know if it'll reach the top there or not. Oh, well, I can, I guess, draw from this peak through the points of tangency. Is that meaningful in any particular way? And I guess I'd get an even bigger tetrahedron than... So I'd been considering sort of this smaller tetrahedron. But I guess we could get a bigger one, and I feel like it would line up with the circle here. Past this point. And at least this one lines up better with the blue one, the one that we've been drawing to help figure out little r. But I don't think I'm going to get anything new from this triangle, or from this tetrahedron. We can try, well, I guess I will get those points of tangency on the side to make some right angles, so then at least I'm using these tangent points a little more efficiently, but if anything, we sort of have a bigger tetrahedron out here. And so r to the side there, that's now like the half the little r, so then we've got sort of 2 big r, and then that's got a nicer ratio, maybe? Alright. Well, the only real new thing I'd get is those tangent lines. So we just draw a circle here, and then we've got these green tangent lines. And they go along the plane. Do they necessarily have to? I feel like they contain the circle. Why should they contain the circle? That's the question. Well, got our point up here. Whoa. There we go. So if we come straight down here, that's this. So these points are contained. These points are contained. I think it's just going to be sort of a similar triangles argument. That the big tetrahedron is now sort of just a widened version of my tetrahedron that had the little r for the radius. So yeah, I think it does pass through down here at the circle. I mean, it almost must. Although maybe we don't even need something like that. So we get these 10s here, but now I get right angles when I connect them up. Does that do anything of any use? So what else do we have? We got root 3 over 2r. These have to be right angles because that's how we figured it out. Figured out by Pythagoras that we have 1/2 400 minus 3r squared in here. And then this is r by 2. And so we've got a bunch of these 10s. That's fine. If I put a dot here, put a check here for those two have to add up to 90. That check there means we get a dot here. And so then r... I want to try and avoid this term if I can. So we get similar triangles, so I'll highlight them. This yellow one is similar to this slightly darker blue one involving our top cone there. And so what's the hypotenuse going to be here? Well, we get r by... Oh, no, this is root 2 r by 2. I was about to say we get a 30, 60, 90 triangle, which would be highly suspicious. We get root 2 r by 2, root 3 r by 2. So squaring that will be 2/4 r squared. And then squaring that will be 9/4 r squared. So we'll get 11/4 r squared up here. And that is to 10 as root 2r over 2 is to... Gosh, I think I need names. A, B, C, D. So we get D is the one with the dot. So D, B, C is to CBA. Okay, so these triangles are similar. So CD over AC, the hypotenuses have the same ratio as DB and CB. Those two, and then those two. Okay, and this should get R just from 10. Yeah. So AC is 10. So we'll have 10 is to root 11 or r over 2. And that's got to be the same thing as root 2r over 2 over root 3r over 2. And what can we do here? So that's root 11r over 20. Divide the 2's out, you'll get root 2r over root 3r. Right? Want to make sure I get the order of those right. Yep. Root 2 over root 3. And actually the r's can cancel out as well. So we get root 2 over root 3. So then I'll get root 33r is the same as 20 root 2, or r is 20 root 2 over root 33. And r, little r, I believe was the value we're looking for. Let's get out our calculators at long last. 20 times square root 2 divided by the square root of 33. And I get 4.923. I thought most of the answers were around the 7s. They were all in the 7s. Okay. So have I jumped the gun? Did I have some similar triangles where I shouldn't? Make sure I remember all my numbers right. I'm happy with the picture, and this should be root 3 over 2r. Right? Should be root 3 over 2r. Let's examine the root 2r over 2 and the root 3r. Or, yeah, root 3r over 2. And make sure they're correct. Oh, you know what? I think that's... Wait, what? I squared. There it is. I was about to say I'm pretty... So what drew my eye was the 11. Because I was thinking, okay, 2 plus 9, but wait, shouldn't it be 4 plus 9? In fact, that's wrong. It should be 2 and 3. So that should be a 5, so root 5. And that means we'll be dividing by root 15. So we're almost doubling it, and that should be around the 7s that I want. So this should be root 5r. And so then that should be root 15. And then this should be root 15. Okay, let's try that again. That's a quick save. I didn't have to go back and analyze a whole bunch of things. Assuming that this works out. So divided by root 15, and I get 7.9 .30296, blah, 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 blah. But this is one of the answers that we are presented with, C, 7.3. All right, that took me a while to see that that final tangents, because I was happy with the tangent points I had used, but I guess I wasn't using them with tangent lines, and I wonder if there was a quicker way to see that. Because I had tetrahedrons. I had equilateral triangles. I just didn't have that big one. And I think that was the key. But we got it in the end. It took a little longer than I'm happy with, although it's a 3D geometry question. Frankly, I'm happy I got it, period. But, I like to be a little faster. Yeah, so C, 7.3. And that finishes up our 2009. This is the last Fermat paper of the aughts. Next will be the 2010 Fermat paper, so we'll be starting the teens, getting closer to present day. Of course, next I'll be doing the 2009 Hypatia, or the 2009 Euclid after that, and then we'll be getting to the 2010s for those contests. So I will see you guys for those. If you care to look for them, they'll be the next videos I post. Thank you so much for watching. Feel free to like or subscribe or any of those things. But, the thing I'd rather you do the most is just keep on doing math contests, keep practicing away, and trying to better yourself. Okay? Have a wonderful day. I'll see you later.